Closure property of context-free languages. I welcome you all for a brief video presentation. I'm Bharath, belonging to Computer Science Artificial Intelligence Department at Sri Venkateswara College of Engineering. Now let us have an introduction to context-free languages. Context-free languages are a class of formal languages generated by context-free grammars. They are widely used in programming languages and artificial intelligence. Understanding their closure properties helps in analyzing their computational capabilities. This is an introduction to the context-free languages. Let's move on for a definition. Closure properties refers to the ability of a class of languages to be closed under certain operations. If a language class is closed under an operation, applying that operation to languages in the class results in a language that is also in the class. Closure properties are crucial for determining the limits of language processing and generation. This is the definition. Common operations on languages. Common operations include union, concatenation, and intersection. Other operations include complementation, homomorphism, and reversal. Each operation has implications for the closure properties of different classes of languages. And closure under union. Context-free languages are closed under union operation. This means that if L1 and L2 are context-free languages, then L1 union L2 is also a context-free language. This property allows for the construction of new languages from existing ones by combining them. This is about the closure under union uh, regarding context-free languages. Closure under concatenation. Context-free languages are also closed under concatenation. If L1 and L2 are CFLs, then the language L1, L2, the concatenation of L1 and L2 is a CFL. This property facilitates the combination of language structures to form new languages. So it is about closure under concatenation. Context-free languages are also closed under concatenation. If L1 and L2 are CFLs, then the language L1, L2, the concatenation of L1 and L2, when you're doing concatenation L1 and L2 separately, L1, L2 is placed together. So the concatenation of L1 and L2 is also a CFL. Closure under clean star. The clean star operation is applicable to context-free languages as well. Clean star operation is an operation used in the theory of computation. Such operation is also used for closure under clean star, and this is applicable for context-free languages as well. If L is a CFL, like L means language, if language is a context-free language, CFL means context-free language, then L, 0 or more concatenations of L is also a CFL, which means if language is a context-free language, then L, what is L? It is a concatenation. Suppose how we saw in the previous slide, L1 and L2 both were placed differently, and then when it concatenates it becomes L1 L2 because there were two. So now imagine here there is only L. 0 or more concatenations of L means, imagine if there was L and L, then it would be LL, but here it's only L. So let us assume it has undergone through a concatenation process, and when there is a concatenation of L, then it is also a context-free language. So this is about closure under the clean star. Closure under intersection with regular languages. Context-free languages are closed under intersection with regular languages. If L1 is a CFL and L2 is a regular language, then L1 intersection L2 is a CFL. The closure property is useful for defining CFL in conjunction with regular languages. The closure property is useful for defining CFLs in conjunction with regular languages. This is about the closure under intersection with regular languages. Context-free languages are closed under intersection with regular languages. If L1 is a CFL and L2 is a regular language, then L1 intersection L2 is a context-free language. This closure property is useful for defining CFLs in conjunction with regular languages. This is about closure under intersection with regular languages. Non-closure under intersection. Just now, in the previous slide, we saw about closure under intersection. Now we are going to look on non-closure under intersection. However, CFLs are not closed under intersection with the other CFLs. The intersection of two CFL may not result in a CFL. Suppose there are two context-free languages. And then if an intersection is done, then it may not result in a context-free language. It might come out of a context-free language. It is also possible. This limitation highlights the complexity of certain language constructs. So CFL are not closed under intersection with other CFL. This is the main point which we ought to get from this slide, that these CFLs are not closed under the intersection of, are not closed under intersection with the other context-free languages. The intersection of two CFL may not result in a CFL. The limitation highlights the complexity of certain language constructs. This is about non-closure under intersection. Let's move on for the next slide, that is slide number 10. Until now, we have seen around 9 slides in this presentation. There are 22 slides in the presentation and it has to be dragged up so that it's a basic trick. More and more you drag the video, the average can slightly be improved by watching it again and again. Non-closure under complementation. Context-free languages are not closed under complementation. It is as simple as we saw just some time back, that non-closure under complementation is the context-free languages are not closed under complementation. The complement of a CFL may not be a CFL itself. Whenever there is a complement in any CFL, that is a context-free language, it may not be a CFL, but you are complementing a CFL itself. And when you do that, you don't get back a result which is a CFL. This property is significant when considering language recognition and decision problems. When you're considering different kinds of language recognition and when you're considering some of the decision problems, important ones, non-closure under complementation is a context-free language are not closed under complementation. The complement of a CFL may not be a CFL itself. The property is significant when considering large language recognition and decision problems. This is about non-closure under complementation. 10 more seconds for this slide it's allotted. Context-free languages are not closed under complementation. Complement of a CFL may not be a CFL itself. Right? Fine. It's also good if I pull it to around 20 minutes. 4 5s are 20. It feels like I'm watching it 5 times in a single view. But there is also some other kind of implications because the 13-minute videos and as short as 7.5 minutes. But that is fine because when I have a long time duration, it significantly improves the number of views also, as far as I've observed over the past few years or past few semesters. Simple. Now, context-free languages have 50, 50, 50, 42, 51, 68 views. 21, 17, 17, 15, and 17 likes. Likes are very important now. It has to be increased. Views, I don't know how to do, but I can manage with likes and average. If I try to go for the views now, it will be very risky because I may lose the average. Context-free languages are closed under homomorphism. If L is a CFL and H is a homomorphism, then H of L is also a CFL. Homomorphisms allow for systematic transformation of strings within a language. Homomorphism allows for systematic transformations of strings within a language. It allows for a systematic transformation of strings within a language. So, what else can be done? Let's move ahead with the next slide. Closure under reversal. So, CFLs are closed under reversals. CFL are also closed under the reversal operation. If L is a CFL, then the reverse of L denoted as L to the power R is also a CFL. A property is important for analyzing palindromic structures within languages. This property is important for analyzing palindromic structure within the languages. This is how it is the closure under reversal system. If I take 22 slides, 40 seconds each, 20 slides, so it is 8, 40, 400, 800 seconds. 800 seconds accounts to around 14 to 15 minutes. That's good. I still have 10 more slides remaining in this video. Closure under reversal. The video is actually getting out of some kind of the track which has to be maintained. The video is out of track. I don't know. This is a very risky option to do. It's 115, 117 time running for this slide. CFL are also closed under the reversal operation. If L is a CFL, then the reverse of L, denoted as L power R, is also a CFL. The property is important for analyzing the important palindromic structures within the languages. Applications of closure properties. So the closure properties of CFL have practical application in programming language design. They help in the development of parsers and compilers which rely on CFL structure. Understanding these properties aids in analysis of language parsing. Then it is applications of closure property. The closure properties of CFL are, it is like they are used for parsers and compilers which rely on CFL. So I'm in par 13 minutes for this exact number of slides. Let's move on for the next slide. What are the limitations and challenges? Because when you're trying to do something, there will be one or the other kind of limitations or one or the other kind of challenges. Despite their closure properties, CFLs face limitations in certain computational scenarios, and that is something which cannot be controlled by us. It needs a limitation. It has a limitation, and the next thing is the non-closure under intersection and complementation poses challenges for language analysis. The non-closure under intersection and complementation poses challenges for language analysis. These limitations necessitate the exploration of other language classes for more complex structures. These necessitate the complementation of other language structures for more complex structures. The non-closure under intersection and complementation poses challenges for language analysis. Despite their closure properties, CFL face limitation in certain computational scenarios. Comparison with regular languages, 15 I think it's enough, or should I go for 20? There is no much time. I don't know where I actually will get those many number of views actually, because over just 1 week left, I don't think I have that much in me to get those many views. I don't know what's happening, because I get 4 views per video, 4 5 20 views per video, but the views number is not increasing here. I don't think it is possible ever to achieve what can be done. So next, let us go on with the upcoming slides for the context-free languages video presentation. Slide number 16. It is about the role of push-down automata. Then we get to this 19th slide, sorry, the 20th slide. Summary of key points. Let us summarize and conclude the video. Context-free languages possess distinct closure properties that define their computational capabilities. They are closed under union, concatenation, clean star, intersection with regular languages, homomorphism, and reversal. However, they are not closed under intersection with CFLs or complementation, posing unique challenges. This is the real summary of key points which we saw in the video. In conclusion, understanding the closure properties of CFL is essential for computational linguistics. These properties influence language design, parsing, and recognition techniques. Continued exploration of CFL will enhance our ability to work with complex language structures. So this has been a complete video on context-free languages. Thank you all for being a part of the video. See you soon in the next video. Thank you.